complex system involving biological, geological, and chemical processes and cycles. This biogeochemical system of spheres and processes is powered mainly by energy from the sun. So how does this occur? You are going to see how the elements are going in a circular fashion, and the whole energy, it's an energy driven process, and the whole energy is derived from the sun. And since this biogeochemical cycles exist, you will find that the environment is working properly, the ecosystems are working properly, because it is working in a cyclic nature. Whenever it is utilized, again it is replenished. That's the beauty of the biogeochemical cycles. So what is biogeochemistry? It is defined as the study of how living systems influence and are controlled by the geology and chemistry of the earth. Thus, biogeochemistry encompasses many aspects of the abiotic and biotic world that we live in. So it's the geology and chemistry of the earth. All of you know what is geology, and chemistry you have learnt it for many years. And most of the environmental problems can be analyzed using biogeochemical principles and tools. These problems include global warming, acid rain, environmental pollution, and increasing greenhouse gases. The tools can be broken down into three major components: elemental ratio, mass balance, and elemental cycling. So the tools and principles of the biogeochemical cycles. So what is elemental ratio? So the important elements are regarded as conservative, that is, they are conserved. Conservative elements are often nutrients. An organism can change only slightly the amount of these elements in their tissues if they are to remain in good health. So all conservative elements are nutrients, and they should be maintained in proper concentration to keep the ecosystem healthy. What is mass balance? Mass balance is used to define the state of the system, that is, net change is equal to input plus output plus internal change. Example is an acidification of a lake. And then comes elemental cycling, which we will be studying just now. Elemental cycling describes where and how fast elements move in the system. Two types of systems are present: open system and closed system. A closed system refers to a system where the inputs and outputs are negligible compared to the internal changes. An open system refers to a system where there are inputs and outputs as well as internal cycling. So you must be knowing in thermodynamics both mass and energy transfer, and mass is not transfer, energy is transfer. So you will have internal changes very less in a closed system, and in open system you will have the internal cycling. Then comes a diagram of the atmosphere, the hydrosphere and the lithosphere. If you have done in your childhood test the Venn diagram, it is very similar, and this is a universal set. The ecosphere is made up of individual ecosystems such as tropical forests, grasslands, tundra, coral reefs and estuaries. As we have seen earlier, matter and energy flow between and within these ecosystems is interconnected biogeochemical cycles. So matter and energy both are flowing, so they are open systems. Gaseous chemical compounds are produced and consumed in the ecosystem and exchanged between them and the air. The most common way of studying the global movements of these chemicals is by mathematical modeling of biogeochemical cycles at the Earth's surface. So all of you are very much conversant with mathematical modeling. So you must be knowing that you can do all predictive models can be done by mathematical modeling, and lots of COVID-19 predictions are being worked out on the basis of mathematical modeling. So you can make softwares which will predict not only COVID-19 but other viruses, bacteria which can cause large-scale harm. And this can be done actually by your changing parameters. So what are the properties of the biogeochemical cycles? Irreversible. System does not return to its exact previous state if it goes through a disturbance. Transitional phenomena. This system tends to be switched from one state to another and another than simply moving from before or after. Third, devolution, in which the system progressively changes in a particular direction. Fifth, processes that either enhance the original perturbation to the system, positive feedback, or relieve, that is perturbation, and that is negative feedback. The most important biological process of all is photosynthesis. You must be knowing that is the only source of energy, and it is the only process by which energy can be fixed. And if these green plants or these trees do not fix the energy of the sun by this process of photosynthesis, then what happens? The whole ecosystem is without any energy or food. It is a photoautotrophic process of photosynthesis, that is autotrophic reaction in the presence of light. Nutrients such as phosphate and nitrate are also necessary for this reaction to occur. Another very important set of biological processes is that involved with the breakdown of rocks exposed to rain, wind and ice. So representing biogeochemical cycles, you have a carbon cycle, and for completeness the biological nutrient phosphorus. So why is phosphorus so very important? Can anybody tell me? If you want, you can write it in the chat box why phosphorus is so important. So the carbon cycle. Carbon composes approximately 50% of all living tissues. In the form of carbon dioxide, it is necessary for plants to grow. Carbon dioxide also helps to sustain an equable climate on the earth, and carbon dioxide is cycled through the spheres of earth on different time scales. You can refer to the scales as short, medium and long term. So the small exercise, first go and see the figure of the carbon cycle. So you have two carbon cycle, one with pictures and another you have the total carbon cycle. So in the lithosphere you have the kerogen, the coal, the oil and the gas. Can anyone please tell me what is kerogen? Please do not mix it up with kerosene. Then from kerogen you get CO2 from cement manufacturing. So CO2 is released. Then you have CO2 burning of coal, oil and gas. From coal, oil and gas. Then these are all the outputs from the soil. CO2 from alteration of organic matter and CO3. Okay, now it's the coming back. So from the atmosphere, CO2 to weathering of limestone and silica. Then living plants extract carbon dioxide and gives you organic matter in plants and animals. Then CO2 released from deforestation or cutting down of forests. Then CO2 from decaying organic matter and respiration. Oceans absorb CO2, and you have hydrosphere where carbon dioxide is dissolved in oceans, and precipitation of calcium carbonate because it binds directly with calcium oxide. Aquatic plants put CO2 in water, and you have in the soil buried organic matter. So this gives you actually an overview of the carbon cycle. So if you are asked to draw anytime, write something about the biogeochemical cycles, then you have to give this flow sheet. So the small amount of carbon dioxide in the atmosphere is the only source of carbon that passes through the organism along with the food chains. Carbon moves from atmosphere to the green plant and then to animals and finally to the other microorganisms that return into the atmosphere through decomposition of dead organic matter. The carbon dioxide has a unique property of absorbing infrared radiation, and it helps in keeping the earth warm, and that is due to your global warming. So, and excess of carbon dioxide need to rise in temperature. So you have two processes, short term, that is photosynthesis and respiration, and the long term includes interconnection between the cycling of the minerals calcium carbonate and calcium silicate. And the last long, that is carbon cycle, 100 millions of years. And some of the animals and plant Plankton sink to the bottom where the carbon in the organic matter shells escapes degradation. So, if all the materials of the earth actually is made up of the elemental carbon, yes, so after each plant and animal dies, so you will have carbon dioxide released into the atmosphere or carbon into the atmosphere. Then when plants die, they actually get buried into the soil, and what you get? You get fossil fuels after some time. Similarly, the stars also die, so the stars also release carbon. So it's not carbon, actually they're made up of carbon. So what happened to the stars when they die? So this long-term carbon cycle. In the long-term carbon cycle, you have these carbon particles become a part of the sediment and are carried along to subduction zones where they are transported down to the Earth's mantle. At severe pressure and high temperatures in the subduction zones, organic matter is decomposed and calcium carbonate reacts with the silica found in the subducted rocks to form calcium silicate. Morphism makes its way into the atmosphere in volcanic eruptions and via hot spring discharges. Then comes the medium time cycle, which is the millions to tens of millions of years, involving storage of carbon in organic materials in sedimentary rocks. Ultimately, this carbon is returned to the Earth's surface and undergoes weathering in the process. O2 is taken out of the atmosphere and carbon dioxide is returned. So this is the schematic diagram. Next we come to the hydrological cycle or the water cycle. I will not go into the details of this water cycle as everybody knows. We will just go through the schematic representation. So you have precipitation of snow, ice, rain that gives water into the soil. Then from the percolation to the land you have groundwater flow. Then you have evaporation, which actually takes away water vapor from the surface of ocean, ponds, lakes, streams, and this leads to the formation of cloud, which again leads to precipitation. And another method of getting water vapor into the atmosphere is the process of transpiration, which is done by plants. Then comes the oxygen cycle. There is also a short-term nearly balanced cycle on land, because the amount of oxygen produced yearly by a land plant is about equivalent to the amount they use in the processes of respiration and decay. On an average, it takes about a decade for oxygen and carbon dioxide to cycle through living plants. It is also available in the bound state of oxides and carbonates in rocks and water. The plants release oxygen in water during photosynthesis. Again, gaseous oxygen is used in the respiration of all the organisms and in the oxidation of the organic matter. Another phase of the oxygen is the ozone layer of the outer stratosphere, which serves an important function of protecting the life from the ionizing ultraviolet rays. So this is what you have studied in your ozone hole. So what happens? Continental rocks give rise to atmospheric CO2 and also from marine sediments. Marine sediments are formed by the marine biota by the processes of photosynthesis and respiration, and on the land biota, oxygen is released by the process of photosynthesis and taken by the process of respiration. Now we come to the sulfur cycle. So the sulfur cycle, eolian emissions of sulfur containing soil dust particles are thought to have increased by a factor of about 2 from 10 to 20 sulfur per year. The input of sulfur, largely SO2, is directly added to the atmosphere from the burning of fossil fuels, metal smelting and other industrial and urban activities. And the deposition flux of sulfur from the atmosphere to the oceans and land surface is increased by approximately 25 to 163% respectively. Just imagine the increase in the amount. The amount of sulfur entering the oceans and river runoff has probably more than doubled due to human activities. So this is how sulfur is generated and utilized in the schematic diagram. So you have volatile sulfur emissions from continents, aeolian emissions, volcanic emissions, and then you have deposition over continents, depositions over oceans, sea salt sulfate, volcanic emission, all sorts of sulfur emissions and sulfur utilization. So the acidity of running water is below 5.6, indicating the main causative agents are carbon dioxide and sulfur compounds and methane sulfonic acid. Within water drops, sulfur dioxide can be quite rapidly oxidized to form sulfuric acid, which makes them a much more acidic since H2SO4 is a very strong acid. And MSA formed by oxidation of DMS by the hydroxy nitrate addition route also contributes to the acidity of atmospheric water. So this is atmosphere. There you have land. So SO4 2 minus dissolved in the oceans can release DMS gas, and this DMS gas causes MSA rain aerosol, and then you have OH and or NO3 extraction of H. So you have H2SO4, and if it drains down, you will feel that it is acidic in nature. So it can become the very most important cycle, that is the phosphorus cycle. I want to answer why we started the phosphorus cycle. So due to decomposition by bacteria and fungi, phosphates and phosphoric acids are released. Phosphates are released by the animals into the soil. Phosphates are also derived from erosion of phosphate rocks. And the living organisms are capable of getting phosphorus and other elements from the environment, and they also have a separate phosphate cycle. So this is how it comes down. So you have the phosphate in soil, consumers, taken as food, then they die, you have decomposers, and here again phosphate in soil comes back. If you have phosphates that comes from plant death, and then from shallow water and water reservoirs, rocks containing phosphates, ecosystem, deep sea. So important notes that the phosphorus cycle occurs naturally in environment, as phosphate or one of its analogs is phosphoric acid in the form of soluble inorganic phosphate ions, soluble organic phosphate ions. And the ultimate source of phosphate in the ecosystem is crystalline rocks from the calcium phosphate or the magnesium phosphate. In the detritus food chain, the phosphate is liberated as an inorganic ionic phosphate because large organic molecules containing phosphate are degraded. In organic form, it can be immediately absorbed by autotrophs, or it can be incorporated into a sediment particle in the soil or in a terrestrial ecosystem or in a sediment of an aquatic ecosystem. The sedimentary phase of phosphate cycle remains comparatively slower than the sedimentary phase of the phosphorus cycle remains comparatively slower than the organic phase. Now we come to the nitrogen cycle. The nitrogen is very much required by plants and for it is an essential nutrient, but incidentally plants cannot fix nitrogen. So it is done by two processes. One of the process is by the lightning, in which in the atmosphere nitrogen is fixed, and by the symbiotic bacteria in the root nodules. So air contains about 78% of nitrogen, and these are the only two processes by which nitrogen can be fixed. So it is found in chlorophyll. Nitrogen is also one of the main constituents of atmosphere, but it cannot be directly absorbed from the atmosphere. In the soil is present in form of organic nitrogen substances and inorganic nitrogen substances, such as ammonia, nitrite and nitrate. In the process of ammunification, microorganisms convert excess amino acids into ammonia, urea and uric acid. And during putrefaction, the combined nitrogen present in them is converted to ammonia and nitrogen compounds. So this is how the nitrogen cycle works. So if we go to the flow sheet, we find that first of all, nitrogen, lightning and electrical discharge is fixing it. Denitrification is just the opposite process of fixation. From this, it goes to nitrates in the soil. Nitrifying bacteria actually denitrifies it, and then again is converted into nitrogen Then you have ammonia and its salts, nitrification, nitrogen. Then from ammonia, absorption by plants. Again, when the plants die and decay, it returns back to the earth's surface. Then plants is taken up as food by animals. Decay and excretion in animals. Again, you get ammonia and its salts released into the atmosphere. And from nitrates in soil, by absorption, you reach the plants. So nitrosifying bacteria present in soil convert ammonia and salts to nitrates. Nitrifying bacteria convert the nitrites to nitrates, and nitrogen assimilated by the plants in the soil is returned back to the soil through ammonification and nitrification. Two types of nitrogen fixation occur: non-biological and biological nitrogen fixation. So this completes the biogeochemical cycles of the elements, and they are very important because they actually serve as a bridge between the biotic environment and the abiotic environment. Now we come to something called the ecological succession. So an ecosystem is never static. Its structure and function changes with time in an orderly way, and such a change can be predicted. So it is defined as, what is it defined? An orderly process of changes in the community, structure and function with time. So it is a time process through modifications in the physical environment which ultimately culminates in a stable ecosystem known as a climax. So structure, community structure, function with time. So the physical environment is continuously changing to give you a stable ecosystem known as climax. So Odum, the father of ecology, says that environmental development, that is, you will have evolution, because if evolution occurs, then that animal actually becomes adapted to the environment and can survive much longer. So it's an orderly process of biological community development that involves changes in species structure. The modification of the physical environment by the biological community and the culmination in a stabilized ecosystem in which maximum biomass and symbiotic function between organisms are maintained per unit area of available energy flow. So we go into the statement one by one. First process is that it should be an ordered process. Evolution cannot be an unordered process because it leads to the development that involves changes in species structure. So you will be finding that in most of the animals there are certain organs which are not required by the body, and they have become appendages, just like your appendix. Okay. Then comes the modification of the physical environment by the biological community. So when the biological community has evolved, what it is doing, it is modifying the physical environment in such a way that is best suited for its purpose. And the last one comes as a culmination in a stabilized ecosystem. So every strata of the ecosystem goes for an evolution. So what happens? You will have a better symbiosis, maybe you will have a maximization of the biomass, and this is maintained per unit of available energy flow. So the community establishing first in the area is called the pioneer community, and in the early stages of ecological succession, the rate of primary production exceeds the total community respiration. This is because the community has not adapted and adjusted itself till then. Neither it has settled, so that you will have a huge usage of the primary production. So understanding energy flow. So it goes from the primary carnivores to the secondary carnivores, to the microorganisms, and in between if you have tertiary carnivores, then the detritus. Then comes the understanding of the energy flow. So in here, you have to take in consideration the two laws of thermodynamics. First one tells that nothing is created nor nothing is destroyed. What happens? One is converted into the other. And the second law states that no energy transformation are 100% efficient. Energy is being transformed with a more useful one to a less useful one. And energy tends to flow from higher level to the lower level. The same thing, actual representation. So next comes the food chain, the food web. Food chain you must be knowing. Food chain is a sequential process of eating and being eaten, which forms a linear chain as called as the food chain. So this is the representation of the food chain. So you have phytoplankton, secondary consumers, then tertiary consumers and quaternary consumers. So you have terrestrial food chain, you have a marine food chain. And then there is a nutritious food chain, which is the decomposer food chain, which actually decomposes all the dead organisms and release all the nutrients back into the soil for a future cycle of the plant. And what is the food web? Different food chains are often interconnected to form the food web. And the interlocking and interlinking pattern of the food chain is called the food web. So this is a food web. Same organism can be eaten up by two different organisms belonging to two different blocks. Okay? A simple system web. So the significance is that the food is also help to maintain regular the different animals and thus help to minimize and food sources maintain regular the population size of different animals and thus help to maintain and regulate the ecological balance. So the same organism can be a part of two different food chain. What happens? It will actually interconnect the food chains and let them come to an equilibrium. So food webs are constructed to describe species interactions, yes. So all species in the food webs can be distinguished into basic species, autotrophs, intermediate species, herbivores, and intermediate levels, carnivores such as grasshopper, scorpion, or top predators. There will be indirect interaction among species, and from primary and secondary consumers, structured food webs such as the productivity and abundance of organisms. At each tropic level is controlled by the productivity and abundance of populations in the tropic level below them. Okay. And then you have a top-down control and bottom-up control of all this. So the population density of a consumer can control that of its resource. For example, predator populations can control the abundance of prey species. So either you have a top-down approach or a bottom-up approach. Then comes food webs can be used to develop different pattern of energy transfer in terrestrial and aquatic ecosystems. So food webs are very, very important. So you have the ecological pyramids of three basic types. Pyramids of number. So it is always upright. And you have an inverted pyramid of number. Then you have pyramid of biomass, which is upright pyramid. But in the aquatic system it is inverted. Okay. Then you have pyramid of energy, which is upright. Then you have the very energy from tropic levels. So this is the pyramid, is the upright pyramid. So then you have in summary, that is how the ecology or the ecosystem actually maintains itself. So biogeochemical cycle can be expressed as a set of stores, pools and transfers which can be studied using the concepts of stoichiometry, mass balance and residence time. Okay.
তাহলে কি হবে? আমার পরীক্ষা নেই। খাইলে মা কিছু করেনি, আমি বাকিগুলো করেছি, যে করাতে করেছি। কার সঙ্গে দেখবে দেখবে, আজকে রাত্রে কাল সকালে দেখবে।